And we are going to start, where is that? Okay. Combinations as well. So when you are doing this counting problems for the first time, right, you should always try to look at simple cases first, okay? So, for example, I was looking at the number of permutations. For example, if I were a student, remember we did the number of permutations of pepper, right? I will go through I will write down all possible permutations of pepper, okay? And I'm also going to write down all possible permutations of pepper if E's were distinct and the P's were distinct. So maybe put P1, P2, P3, and E1, E2 to make them distinct, and write down all possible permutations and see how you're going from one number to the other. Is that making sense? So that's going to give you more intuition on this type of problems. Okay, so what is a combination? So consider a group of three objects, let's say A, B, and C, and a combination of these three objects taken two at a time is just a subgroup of size 2. It's just a subgroup of size 2. So what are the possible subgroups of ABC of size 2? Well, it could be AB, it could be A and C, it could be B and C, right? Those are the only possible subgroups of size 2. So when you are looking at a subgroup of size 2, you don't care about order, right? Is everybody okay? In other words, what I have here is the number of unordered arrangements of two objects, right? So here, order doesn't matter. Am I making sense? So for example, let's say if I pick 3 students from the class according to their class ranking, say 1, 2, and 3, right? If I'm picking 3 people from this class according to their final class ranking, let's say, then what are the possible outcomes? Well, in that case, I should be looking at the number of permutations of the students that I have here taken 3 at a time, right? That should be the possible, those are the possible outcomes. On the other hand, from this class, if I am just picking, if I'm making a committee of 3 students, right? If I'm picking a committee of 3 students, then what should be the answer? Well, it's just a number of subgroups of 3 students, right? Right? Order wouldn't matter in that question, right? In the first question, order matters. In the second question, order doesn't matter. You agree? Okay, so we are going to use the notation C32 to denote the number of combinations of 3 objects taken 2 at a time, and we just saw that answer is 3. Any questions on this example? So generally, What is a combination? Well, actually, let's do this example next time because we don't have time. Let me show you the general. Okay, that's just the theorem. So generally speaking, let me just end by saying this. Generally speaking, if you have n objects, then the number of then what is a combination of n objects taken k at a time? A combination of n objects taken k at a time is just a subgroup of size k, right? So when I say what is the number of combinations of n objects taken k at a time, all I mean is what the number of subgroups of size k taken from a group of n elements, right? Is everybody clear? So that's what we're going to look at next time.